Hello everyone, today we're looking on another interesting problem, which is merging linked lists. So we're given two sorted linked lists and we need to match it into one list. So basically, for example, list 1 is 1 next 2 and list 2 is 0 next 3, and we want to have a result which is 0 next 1 next 2 next 3. Okay, so every time you hear the word sorted in a problem, it means that it is better to use it. Okay, so the expected time complexity here for this problem is time linear and space constant. So you shouldn't allocate any extra space here. Okay, so how can we approach this? Basically, well, you need only one iteration, and basically you need one sentinel, which is going to you use to connect all the nodes together in the result. I will show you how it works. Okay, first of all, let's declare a node class. Okay, then for better debugging, we let's declare a representational method. Basically, we need what for representation of this. We need to have store result as a string. A result is self val. Okay, and so if self next exists, we want to just attach it to result. And here we want to return result. Okay. So now, okay, now we have our list 1, which is node 1, node 2, list 2, which is node 0, node 3. Okay. And yeah, let's just print a list to see how it looks, how looks the representational part. Okay, it works. So you see that we can represent one object as a string, which is 1, 2. Okay. Okay, so now let's go to the solution. Def match lists L1, L2. Okay, first let's return none. Okay, just to have our solution code. Okay, so what do we expect here? Here we expect a string which is 0, 1, 2, 3. Okay. Okay, now it returns none. Okay, and we are going to solve this problem. So, as I already told you, we need a sentinel to which we attach all the nodes in a sorted order. Sentinel. Depart -1. We need current to as a current node. So, and we loop while L1 and L2 we check if L1 value is less than L2 value. Okay, it means that we want this value assigned next to sentinel. which is current. L1, this node, okay, and we want also to walk next, L1 next, because we just operated on this node already, and else we want to the current next to be L2 node, and we want to walk L2 to the next. Okay, and we want to walk our current too in the end to proceed. Okay, now we should not forget that basically one list can be shorter than another list, and we want to check if we have a leftover, we need to append this leftover to our result. So basically current next equal to L1 if L1 else L2. Okay, and we need to return sentinel next. Okay, let's see. Yeah, result 0, 1, 2, 3. So we merged our two lists. Okay, let's debug it. Let's look how this method works in debug. Okay, so breakpoint here. Okay, at this point we have what? We have L1 created, node with value 1, next node with value 2, and L2 points to node with value 0 and with next to node with value 3. Okay, two lists we have. Okay, we declare sentinel and current. So we see the sentinel now is a node with value -1. Okay, next none. Okay, we go into the loop, and so we check if L1 value is less than L2 value. L1 value is 1, L2 value is 0. So L2 value is clearly less. So basically to the current, which is, you see the pointer which points to the sentinel, we attach a current next L2, which is not with value 0. You see, and now this arrow, it shows that we point to the node with value 0 already, and L2 also points to it, but it is not a problem because next we walk L2, and now L2 points to the next node, which is node with value 3. So the result looks like now -1, next 0, next 3. Okay, we walk next, now it is 0. Okay, and we decide again what is less, L1 or L2 current. Current L1 is, you see the arrow, it points to the node with value 1, and current L2 points to the node with value 3. Which is lower? Lower is of course 1. So we're going to assign it to the current, and you see current now again point to the node with value 0. When we assign to it, you see this node points at the node on value 1 now, and we walk L1 to the node of value 2 and walk current, and here we on the node with value 1. So good, we have now the as result -1, 0, 1, 2. You see we already have it sorted. You see it's very helpful here on a node we see representation already -1, 0, 1, 2. So basically we see how it is sorted. Okay, and the next we check L1 is pointed to 2, L2 is pointed to 3. So we check who is smaller. L1 smaller, of course. Okay, So we walk current points on our node with value 2. Okay, and we have leftover. You see the leftover I talked about. We have L1 is equal none, but L2 is equal one node with value 3. So the condition says if L1 is something we just appended, else we append L2. Okay, and you see we append L2 to their current. So current is now -1, 0, 1, 2, 3. You see all those nodes linked together. Okay, -1, next 0, next 1, next 2, next 3. We have it sorted, and now we must return the sentinel next. Okay, just we don't want to return this -1, and we have our result. All nodes linked together as it's supposed to be. So yeah, that's it. Basically, again, it is the speed, the time, complexity here is linear. You do one iteration, and the space complexity is constant because you don't allocate any extra space. Okay, well, thanks for your attention. Have a nice day.